Okay, so the question is to find out the angle between two lines, and to find the angle between two lines we have a formula: cos theta is equal to absolute value of b1 dot b2 divided by modulus of b1 into modulus of b2. So I start with the first line. The first line is x minus y is equal to 3. I try to put this line in the standard form, so I get y is equal to x minus 3. By rearranging, I shift minus y to the other side. So that's y is equal to 1x, 1 by 1 x minus 3, 1x. I just wrote it as 1 by 1. So I know the gradient is 1, which is 1 by 1, which is actually rise over run. Now rise stands for vertical movement, vertical, and run stands for horizontal. Now using this, I find my direction vector of the first line, the direction vector b1. Vector is always horizontal first and then vertical. So the horizontal has to come here, horizontal, and then vertical. So b1 vector would be horizontal. Horizontal is run, which is 1, and vertical is rise, which is 1. So that's my b1 vector. I found my b1 vector. Now, so that's my b1 vector. I have my b1. So now the second line. Second line is 3x plus 2y is equal to 11. I try to make y as a subject. So 2y is equal to minus 3x plus 11. So y is equal to minus 3 by 2x plus 11 by 2. Therefore, the gradient m is minus 3 by 2, which is again rise over run. Rise stands for vertical, run stands for horizontal. So I have my b2 vector. First, the horizontal. Horizontal is run, which is 2. Then vertical. Vertical is minus 3. So that is my p2 vector. Again, I just want to write it and keep. First comes horizontal. Horizontal means run. Then comes vertical. And vertical means rise. So that's how I have 2 minus 3. So now that we have both b1 and b2, I can calculate the angle between the two lines. So cos theta is equal to absolute value of 1 1 dot 2 minus 3 divided by modulus of b1, root of 1 square plus 1 square into root of 2 square plus minus 3 square. Now for dot product, I multiply the I coefficients together. I say 1 into 2 and then plus 1 into minus 3. Multiply the I coefficients together. 1 into 2 is 2 plus multiply the j coefficients together, which is 1 into minus 3 is minus 3. Absolute value, of course, divided by root 2 into root of 13, which is minus 1. Now absolute value of minus 1 is 1 in the numerator, so divided by root 26, and so theta would be cos inverse of 1 by root 26. Let's quickly see one more question. Question C. So question C. Y is equal to minus x plus 7 by rearranging. So gradient is minus 1, which I read as minus 1 by 1, which is actually rise over run. When I say rise over run, that's vertical over horizontal. So b1 vector would be horizontal comes first and then vertical, 1 minus 1. So that's b1 vector. With the second line is x minus 3y plus 2 is equal to 0. I move 3y to the other side. So 3y is equal to x plus 2, y is equal to 1 by 3x plus 2 by 3. So the gradient would be 1 by 3, which is rise vertical run horizontal, rise over run. Therefore, my B2 vector would be horizontal, which is run, and then vertical, which is 1. So we found both B1 vector and B2 vector. So using them, we are going to calculate the angle between the two lines. Cos theta is equal to absolute value of B1 dot B2 divided by modulus of B1 into modulus of B2. So absolute value of B1, 1 minus 1 dot 31 divided by modulus of B1, root of 1 square plus 1 square, the root of 3 square plus 1 square. So 1 into 3 is 3 plus 1 into minus 1 is minus 1 divided by root 2 into root 10. So I get it as 2 by root 20. You could leave it that way, or it simplifies as 2 by 2 root 5 because 20 is 4 times 5 and 4 becomes 2. So theta would be cos inverse of whatever we have here, 2 by 2 root 5. Look at this question. This is exercise 13E, question number 1 we are going to see. And the question says, find the shortest distance from a point P32 to this line. So the line's equation in parametric form is given to you. A parametric form means the value of x and y is given in terms of the parameter t. So for different values of t, it gives me different points on the line. So I'm going to draw a line first. So let's say that's the given line. Is the given line L. Question A here. So we have a line L, and its equation is x is equal to 2 plus t and y is equal to 3 plus 2t. So from this equation, I can pick up the direction vector for the line. The direction vector is the coefficient of the parameter. So if you look at the equation, or maybe if I write it like the vector form, it is xy is equal to 2, 3 plus t times 1, 2. It's the same thing. When I equate the I coefficients, I'll get x is equal to 2 plus 1t, and when I equate the y coefficients, the j coefficients, I'll get y is equal to 3 plus 2t. Yeah. So I know the direction vector is this one then. Or rather, I could have picked it up directly from the equation. You look at the equation, the coefficients of the parameter will give me the direction vector. 1, 2 is the direction vector. So this line has a direction vector b vector, which is vector 1, 2. I got it from the coefficients of the parameter 1, 2. So that's the direction vector. Then they said there's a point P which is 3, 2, and what they need is the shortest distance. And the shortest distance is always the perpendicular distance. So from P, I draw a perpendicular to this line, and let's say the foot of the perpendicular is Q. So what I need is the distance PQ. Since the equation of the line is given in the parametric form, x is equal to 2 plus t and y is equal to 3 plus 2t, this is actually, this is any general point on the line. For different values of t, it gives me different points on the line. Any point, any general point on the line. If it is any point, any general point on the line, it could also be q. So I'm going to say, therefore, let q be 2 plus t comma 3 plus 2t for some value of t. I don't know for what value of t, which I'm trying to find now. For some value of t, for some value of t. I'm going to find out what is vector pq. Vector pq is oq minus op. OQ is 2 plus t, 3 plus 2t. That's my OQ vector. Minus, that's t2 plus t here. Okay. Okay. So OQ vector minus OP vector is 3, 2. And to subtract two vectors, you subtract the I coefficient. So 2 plus t minus 3 will give me minus 1 plus t. 3 plus 2t minus 2 will give me 1 plus 2t. So that's my PQ vector. I can see, if I look at the diagram, I can see PQ is perpendicular to this line, or rather I can say PQ is perpendicular to B vector. So PQ vector is perpendicular to B vector, therefore PQ dot B vector has to be equal to 0. So what's my PQ vector? PQ vector is minus 1 plus t, 1 plus 2t. That's my PQ vector, which I found already. Dot B vector, which is 1, 2, is equal to 0. Now dot product. How do you take the dot product? Multiply the I coefficients. 1 into minus 1 plus t plus 2 into 1 plus 2t is equal to 0. Open the bracket. Minus 1 plus t plus 2 plus 4t is equal to 0, which implies 5t is equal to minus 1, t is equal to minus 1 by 5. So found the value of t, so you put that back into q, so I'll get the point q. So q is, replace t by minus 1 by 5. So 2 minus 1 by 5, comma 3 plus 2 into minus 1 by 5. So on further simplification, I'll get this as 9 by 5, comma 15 minus 2, 13 by 5. That's the point Q. And we already know what P is. P is 3, comma 2. So you choose one of them as x1, y1 and the other as x2, y2. Aren't we trying to find out the distance, this distance, PQ? So the shortest distance from P to the line will be PQ, which is root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared. So that's going to be root of x2 minus x1, 3 minus 9 by 5 the whole squared plus 2 minus 13 by 5 the whole squared, which is root of 15 minus 9 is 6 by 5 the whole squared plus 3 by 5 the whole squared, which is root of 36 by 25 plus 9 by 25, which is root of 45 by 25. Root 45 by 5. Root 45 is 3 root 5 by 5 is the distance. So this calculator, you could do some of these calculations on your calculator, type it in and get the answer. So that's the shortest distance. Let's try one more question. Okay, maybe D, question D. So look at this question D. So I have a line given to me and a point, and the question says find the shortest distance from S to this line. So I'll draw a line first. So I have this line given to me. So I draw a line, and on this line I have a direction vector B vector. Which is the B vector? B vector is t times what is written is here B vector. So B vector is 3, negative 7. Then there is a point S, 5, comma minus 2. So you want the perpendicular distance from S to the line. So from S, shortest distance is always perpendicular distance. I draw a perpendicular, I call the foot of the perpendicular as Q, and that's what we are looking for. So I'm going to write first I'll write the parametric equation. X is equal to what? What is x? X is equal to, equate the I coefficients, then equate the j coefficients. So x is equal to 2 plus 3t and y is equal to 5 minus 7t. This is any general point on the line. If it is any general point on the line, we say let it be Q, because Q is also a point on the line. If this can be any general point on the line, if this is any general point on the line, let it be Q. So I'm saying let Q be 2 plus 3t and 5 minus 7t for some value of t. Then we find vector SQ, vector SQ. And what is vector SQ? OQ minus OS. OQ is 2 plus 3t, 5 minus 7t, that's OQ, minus OS is 5 negative 2. And so when you subtract it, you will get minus 3 plus 3t and 7 minus 7t. 2 minus 5 is minus 3 plus 3t. 5 minus minus 2 is 7 minus 70. That's my SQ vector. And now I'll say SQ vector is perpendicular to the line. Or rather I can say SQ is perpendicular to B vector. Therefore, SQ dot B has to be equal to 0. So I look at my SQ and B and take dot product. B is 3 negative 7, SQ is this. Take the dot product, multiply the I coefficients. So 3 into minus 3 plus 3t minus 7 into 7 minus 7t is equal to 0. So that's going to be negative 9 plus 9t, negative 49 plus 49t is equal to 0. So I'll get negative 58 plus 58t is equal to 0, which implies t is equal to 1. I solve for t is equal to 1. So since I know the value of t, I can calculate the point q. Therefore, the point q is, make t as 1 into q. So that's going to be 2 plus 3 comma 5 minus 7. That is 5 comma negative 2. So that's my point q, and I already know what my s is. S is 5 comma negative 2. So very strange, the 2 points happen to be the same. So that means basically the point S lies on the line. That's meaning we could quickly check whether it is true. If t is equal to 1, x is 5 and minus 2. Yeah, that's true actually. So S is this. So anyway, we were trying to find out, as a general method, we say we are trying to find out the distance between the 2 points. So what we are looking for is SQ distance. And SQ distance will be root of x2 minus x1 the whole squared plus y2 minus y1 the whole squared. So which is actually 0, because 5 minus 5 is 0 and minus 2 minus minus 2 is 0. So the distance becomes 0. So that's a procedure. The thing is, we didn't notice that 5 minus 2 is actually already a point on the line. Okay. Okay, so we have an application question on it. Okay. The same concepts, an application question. It will be easier if you always give a diagrammatic representation to whatever they say in the question. So I'm going to draw the x-axis, y-axis first. So I have the x-axis and y-axis drawn, and then they are talking about an ocean liner which is at 6 minus 6. So I take 6 minus 6 is somewhere here. So that's the ocean liner at 6 comma minus 6. And it's cruising at 10 kilometer per hour in the direction minus 3, 4. So minus 3, 4 direction. So 3 units to the left side minus 3 and 4 units up. So some other 3 units to left and 4 units up. So the line should be, okay, let me just quickly mark this, remark it. Okay, 4 units up. So I draw a line joining the two. So that's the direction in which the liner is going. So that's how it goes. So you have the point where it crosses the x-axis there, the point where it crosses the y-axis out there, and this the origin 0, 0. That's where the fishing boat is. They said boat is anchored at 0, 0. Now your question, find in terms of I and j the initial position vector of the liner. The liner is at this point and they want that initial position vector in terms of I and j. So that will be 6i minus 6j. B part. Write an expression for the position vector of the liner at any time t's. So you want to find out an expression for the position vector after t's. After t's, we don't know where it is. It could be here, or it could be here, it could be here, it could be here. So they just want a general point on this line where the liner is traveling. So if I need a general point on this line, isn't that the equation of the line? So indirectly they are asking for the equation of the line. And to write the equation of the line, I need 2 points. One is an A vector, and A vector is 6 minus 6, the point through which the liner is passing, the initial point. And then I need a direction vector. And the direction vector is also given to you. The vector, the liner is going in the direction minus 3, 4, they said. So the equation of the liner will be r vector is equal to a vector plus t times b vector. R vector is xy is equal to a vector is 6 minus 6 plus t times b vector is minus 3, 4. I'm going to write the parametric form of it. So equating the I coefficients, x is equal to 6 minus 3t, equating the I coefficients from both sides, and y is equal to minus 6 plus 4t. So that gives you any general point on this line. They wanted an expression for the position vector. So the position vector will be 6 minus 3t minus 6 plus 4t. The position vector of any point xy on this line. The C part of the question, it's asking when will the liner be due east? Due east. So this is north, this is east, due east is here. That's due east. So due east, when they say, means the liner is along the x-axis. That's the meaning. And on the x-axis, y coordinate will be 0. So I make the y coordinate is equal to 0. Minus 6 plus 4t is equal to 0. So t is equal to 6 by 4, which is 1.5 hours. So it takes 1.5 hours for the liner to go from the initial point 6, 6 to reach the point where it crosses the x-axis, which is due east of the fishing boat. So that's the time when they ask. It will take 1.5 hours for the liner to be due east of the fishing boat. The last question, find the time and position of the liner when it is nearest to the fishing boat. Time and the position of the liner. So that's like the nearest will be perpendicular distance. So like that, right? That's the distance. That's the position what they are asking for when it is nearest to the fishing boat. So theoretically, if you approach that, they are asking you to find out the foot of the perpendicular, the foot of the perpendicular from F to the line. So I'm going to redraw that. Okay, so here I have already drawn that. So this is the path along which the liner is going. Here you have the Here you have the fishing boat, and when the liner reaches here, the perpendicular distance will be minimum. The nearest to the liner will be nearest to the fishing boat at that time. Since I know the equation of the liner in the parametric form, that gives me any general point on this line. So let it be R, I say. So R is already marked like that. That's my R. And I want the shortest distance. And for that, I'll find out vector OR. Vector OR is perpendicular to B vector. So vector OR, or actually this is called F here. So I find vector FR. Vector FR is OR minus OF. OR is 6 minus 3t minus 6 plus 4t minus OF is 0, 0. That will give me 6 minus 3t minus 6 plus 4t. And then FR dot B has to be equal to 0. So that will give you the time when it is going to be the nearest. FR dot B is equal to 0. So you write here FR 6 minus 3t minus 6 plus 4t dot B is minus 3, 4. So this is equal to 0. You solve this, get the value of t, and go back to the question, read, and accordingly finish your question. Okay. Basically, that's the approach.